Hello and warm welcome to the video. In this video, we are going to discuss the construction of SRAM cell with 10 transistors. So we will also compare it with SRAM constructed using 6 transistors. We will also understand why this SRAM cell with 10 transistors is called as a dual port memory, whereas SRAM cell with 10 transistor is a single port memory. We will also understand what are the advantages of dual port memory. We will also discuss the read operation of SRAM 10T and do simulation using Cadence Virtuoso. So this picture shows 10T SRAM. We have two separate word lines, write word line and read word line. SRAM 60 has only one word line. Hence, this is called as dual port memory, whereas SRAM 60 is called as a single port memory. So we can see that the read word line is connected to gate of transistors M1 and M4, whereas write word line is connected to the gate of these two transistors. So this is a dual port memory, so we can perform simultaneous read and write operation. Also, this is free from read disturb issue, which was major problem in SRAM 60. In SRAM 60 there was only 2 bit lines. Here we have 4 bit lines, 2 for write and 2 for read. The write operation is similar to the 60, only difference is in read operation. The read path is shown in red color lines. So for read operation, first we pre-charge the RBL and RBLB to logic high and then make RWL high. So if Q is equal to high, then M2 transistor is on. Therefore, RBL discharges through M1 and M2. Whereas RBLB will stay at logic high. So M1 and M2 discharge RBL, whereas RBLB stays at logic high because QB is at logic low. Hence, this is the read operation first. Now, if QB is equal to high, then we can see that when we assert RWL, then the transistor M3 and M4 turn on, so they discharge RBL. RBLB discharges through M3 and M4, whereas RBL stays at logic high. So this is the second read state. So if QB is high, RBLB discharges, whereas RBL stays at logic high. So please like and share the video and subscribe the channel. And now let us move into the Cadence environment to do the simulation. So this is the schematic of SRAM with 10T in Cadence. So as you can see, we are using these two transistors to pre-charge the RBL and RBLB to logic high or 1.2 volt in this case. Let us do the simulation. So we are doing a transient analysis. We will be performing the transient analysis. So first we will make Q equal to low and Q bar equal to high. In the first case, we will make Q equal to low and Q bar equal to high and see the behavior of RBL and RBLB. So this is a differential read. One of the bit line will discharge, other bit line will maintain its voltage. So let us see the stimuli. So we are using a RWL of voltage 1.2 volt and period 0.5 nanosecond. So these are the simulation results. We can see that Q is initially Q is low and Q bar is high. So when we assert RWL, then RBL remains at logic high, whereas RBLB will drop. So we can see the RBLB drops to almost 10 millivolt, whereas RBL remains at logic high. So when Q bar is high, the RBL remains at logic high and RBLB drops when Q bar is high. Now let us see the second case when Q equal to high, logic high, and Q bar equal to logic low. So you can see this is the opposite case. Q is logic high and Q bar is logic low. We can see that in this case the RBL line voltage drops when we assert the read word line. So when we assert read word line, then the voltage of the RBL read bit line drops, whereas the voltage of read bit line bar stays same at 1.2 volt. So this is the second phase of the read operation. We are reading Q bar. So in this way we can read both the values of Q and Q bar using a differential read mechanism. So this SRAM 10T uses differential read mechanism. So this is the video. Thank you. Please like, share and subscribe.